G'day girls, today's lesson is going to be looking at mixtures, and we'll also focus on a particular type of mixture called a solution. So firstly, looking at what a mixture actually is. Pretty much whenever we take two or more pure substances and combine them, we can create a mixture. Now there's different types of mixtures because different substances will combine differently and different states of matter will combine differently. Okay, but what we've got to take into account is it's that combination of two or more pure substances. One thing we need to be able to do with the mixture is separate it back into those pure components. So for example, if I was to combine water and sand, I could evaporate the water out and collect the sand back. If I was to combine salt and water, I'd be able to evaporate the water off and collect the salt. So we've got to be able to separate it back to its pure components. First type of mixture that we're interested in is what's called a solution. Now you'd be familiar with solutions. Salt water is an example of one, even something like water with sugar in it, a coffee, these sorts of things are examples of a solution. A solution is formed when one substance dissolves into another. So what we need is two components. Okay? We need a solvent and we need a solute. So you'll hear me go on about salt water throughout this, and that's because it's really our best example of a solution that you'd be familiar with. Let's use that as an example to understand solvents and solutes. So a solvent is the substance that our other component will dissolve into. So if we're looking at salt water as an example, the water itself would be our solvent. The solute is the substance that gets dissolved. Okay, so in this case it would be the salt. You'd be familiar with other ones. So for example, if you were to put water and sugar together, the sugar would dissolve into the water, so the water again would be the solvent, and the solute in this case would be sugar. Other ones that you might be aware of are nail polish and nail polish remover. So nail polish in this case would be the solute because it's the substance that dissolves, and the nail polish remover would be your solvent because it's the thing that's doing the dissolving. If the substance does dissolve, then we say it's soluble. And we can normally tell if something's dissolved because it will form a clear solution. Okay, so over here we've got an example of a copper sulfate solution. You'll notice that it's clear. Light passes through it the same way you'd expect it to pass through water. So in terms of the states of matter that can actually form our solutions, there's four combinations that we commonly deal with. We've mostly talked about, and you'd probably be most familiar with, solids dissolving in liquids. Liquids can dissolve in other liquids though. So for instance, if you've added dishwashing detergent or laundry detergent to water, that's an example of a liquid dissolving in another liquid. If you've had a can of soft drink, and you've noticed that gas comes out of the drink, that gas has been dissolved in the liquid, so we can actually dissolve gas into a liquid. Another example is oxygen dissolving in the water is how fish are able to actually get oxygen into their blood. The other thing that gas can dissolve into is other gas. Now that basically is what creates air. Okay, so air is a mixture of different gases dissolved into each other. It doesn't happen at particle level, it's more so just the combining of the particles into that mixture. So there's a couple of interesting things that you also need to be aware of. The first is that the amount of solute that can go into a solvent depends on the temperature of the solvent. So basically, the hotter it is, the more solute you're actually going to be able to dissolve. This means that hot water you'll be able to dissolve more salt or sugar into than if it was cold water. The other thing is, liquids only have a certain, or solvents only have a certain capacity to dissolve a solute. What can happen is that can reach the capacity, and what you'll notice is some of the solute will form at the bottom or settle at the bottom of the container. You might have seen this if you've ever made jelly, and you've noticed that after you've dissolved the jelly crystals, there's still some jelly crystals at the bottom of the saucepan or whatever container you're doing it in. That's what's called your saturation point, and it creates something called a saturated solution. The final thing that we need to know about a solution is what's called concentration. So Solutions can change in their concentration depending on how much solute is dissolved in the solvent. An example of this is cordial. So imagine that you just get a glass and just pour straight cordial syrup into it. Okay, if you drank it, it would taste gross. But you've got basically a high concentration of cordial syrup in that glass. Now, as you add more and more water, the concentration of that cordial decreases. Okay, one way of saying that is that we're diluting the concentration. So here's an example on the left here of a high concentration. You can see that it's darker in colour, whereas our lower concentration over here on the right is lighter in colour. Now that's all well and good if we're dissolving something that's coloured, but not everything we go to dissolve is coloured. So we can't just use colour as an indicator of how concentrated or how strong something is. That's another way we can talk about this. Okay, something that's really, really concentrated, such as this one, we might say is a higher concentration or it's stronger. Something over to the right here, we would say is a lower concentration, or it could be called weaker. Okay. The other way to refer to something like this, like I said previously, is as being more dilute or diluted. We can calculate the concentration, and we'll do a couple of examples of this in class, but if we want to calculate the concentration, what we need to know is the mass of our solute that we've used and the volume of the solvent that we have. If we know those two things, we can do a simple calculation where we divide the mass by the volume, and it will tell us our concentration of that solution. And that's it for solutions. Thanks, girls.